So we are going to go with this third one, then after that second one. It's very easy. Any doubt? So very important thing is when k equals k prime, this becomes 1. Similarly, when k prime equals minus k, this will become 1. That's all. So at the time k prime is replaced with minus k. Okay. Other things and all same. So now we'll go for pi dagger and pi x. So we know the expression for pi x, and taking the complex conjugate, that will give you pi dagger. So we know already these expressions which we learnt in real scalar fields. Okay, so they are all field operators. They have written in terms of creation and annihilation operators. Now third term of modified Klein-Gordon equation through field operators. So it becomes pi dagger phi, which is equal to, this is your pi dagger multiplied by pi. This is your pi dagger. This is your pi. You are going to multiply these two. So this will become 1 by v. As I said, 1 by v d cube integration d cube x, which is equal to 1. So that will go off. You have sigma over k comma k prime. So there's a mistake here. K comma k prime. So h bar by 2. We can take it as, pull it out. So h bar by 2, 1 by root of omega k prime. And this is your phi dagger. This is your pi. Now you are going to multiply this one first, then you are going to multiply this one, then you are going to multiply this one, and you are going to multiply this one. So we will have 4 terms. As usual, same procedure. So we will go for first term alone. Now ak prime minus ak plus. I have written like this. Usually we will write with the k first and k prime second. So that's why I have written as ak plus ak prime minus. For all the terms I have written like this only. Okay, so this multiplied with this will give you k prime k, but usually you will write k and k prime. So next, this term e power minus ik prime x multiplied by e power ik x will give you e power I, this is your plus, so e power ik minus, this is your minus, so minus k prime x. Any doubt? Come on. Now we will go for this term and this term. So as usual we will have to write ak minus dagger. ak minus dagger. See, ak minus dagger. And this term will be ak prime minus ak prime minus. And this term will be e power minus ik dot x. This will be minus. So I can pull minus I out. So k plus k prime x. Similarly, you can go for this term and this term, that will give you these two terms. Any doubt? As usual, same argument. First, we will have to go for this very simple one. When k equals k prime, this become del k prime. When k equals k prime, we will give you del k prime. When k equals k prime, del k prime equal to 1. So so this term becomes exactly ak minus dagger, and this term becomes when k equals k prime, so ak minus. Is it okay? Similarly, you can go for k and k prime. See here, and you can, this k prime will become k. So this term. Here k equals minus k prime, or otherwise k prime equals minus k. So wherever you can find k prime, you have to substitute with minus k. See, minus k. And here also k prime is replaced by minus k, so you have written minus k. Any doubt? So here too we have 4 terms. So we have found out for the second expression, pi dagger pi. We have found out the second expression. We have found out the second expression. Any doubt? Now your assignment will be, you have to find out the second term. This is your third term. This is your second term, del pi whole square. How to do? It's very simple one. We have the expression for pi and pi dagger. We have the expression. You have to differentiate first with respect to x. Del phi stands for partial d by dx. So you have to differentiate with respect to x. So you are going to differentiate this one with respect to x. That will give you e power ikx. Differentiating x with respect to x will give you ik. So here you will have minus ik. Just take the complex conjugate, will give you del phi whole dagger. Take the complex conjugate. You will get exactly like this expression. Is it okay? Any doubt? So we have found out three terms in modified Klein-Gordon equation in terms of field operators, phi and pi. So we can insert. So we have found out this one, we have found out this one, and this will be your assignment, as I said, and the answer is exactly as in equation 10.105. So just a substitute here. They are going to substitute for all the field operators, expressions for all the field operators. So we have used for pi dagger pi, del phi, dagger del phi. This will be your pi dagger pi. Three terms we have used. See here, this is your pi dagger pi, del phi dagger del phi plus m squared pi dagger pi. See, we have used. Any doubt? Now this minus sign, I can pull it inside, so that will give you this minus sign. Then m squared is replaced with the expression omega k squared minus k squared, which we have learnt already in real scalar fields. M squared equals omega k squared minus k squared. So m squared is replaced by omega k squared minus k squared. That's all. We have not done anything. Just we have taken this minus sign inside. That's all. Then other thing will be m squared is replaced by omega k squared minus k squared. That's all. Equation as it is 10.106 and 10.107 are the same. Any doubt? Okay. Now here omega k squared minus k squared. So I can multiply. So we will have four terms now. Omega squared multiplied by this term, k squared multiplied by this term. So we have now four terms. See here, this is same term, and here we have multiplied by omega squared. Here you have multiplied by minus k squared. That's all. This omega k squared and omega k, that will get cancelled. You have h bar omega by 2. Here also you have h bar omega by 2. So we can add these two. Simple. Here these two terms are same, we can add these two. Okay. Now listen to me, it's a very important one. So as I said, all the terms in bracket, they contain four terms. The first term also four terms, second, third, fourth, all four terms are there. Now you just take second term. The logic is ak minus dagger. Ak minus dagger is ak plus. Is it okay? Ak minus dagger is ak plus. You have ak plus. AK plus dagger is A minus K minus. This is in the negative direction. Minus K negative. Momentum is negative. So both the terms will get cancelled. Even though it is minus minus here, the logic is AK minus dagger is AK plus. Here in this term, AK plus dagger is A minus K minus. So both are the same. But this is AK minus, so negative momentum. So these two terms will cancel. Similar argument for these two terms, similar argument for these two terms, similar argument for these two terms. So as usual, AK minus dagger, you are going to take the complex conjugate, that will give you AK plus dagger will give you A minus K minus, and with the opposite momentum, so both will get cancelled. So you have now these two terms here, these two terms here. So we have two terms. These two terms I have written like this. I have added these two terms. This term, this term with this term, this term with this term. See here, I have added these two terms and I have written like this. I repeat, come on. See here, blue color, AK minus dagger, A minus K plus dagger, the same term. So I have added these two and I have written here. This term AK plus A minus K minus, and this term is same similar term I have added here. Any doubt? Is it okay? Just look at this term and this term. They are similar. Look at this term and this term. They are similar. So I have added these two. That's all. Here this term and this term I have written like this. This term and this term I have written exactly like this. These two terms are similar. Correct? These two terms are similar. Okay, in the next slide, see I have written 2 times. I have taken common out and I have added these two. Any doubt? I have written exactly as it is. As it is. So these two and these two get cancelled. Here too, these two common we take it out. These two and these two will get cancelled. You have this term, and here too these two terms I can pull 2 out. So h bar omega by 2, 2 will get cancelled. You have h bar omega, the remaining terms. Get it out? Now similar argument. AK minus dagger. So that will become AK plus. See, AK plus, and here it will be A plus K minus. We are going to take dagger, so that will be in the opposite momentum. Both will get cancelled, so second term will become 0. You are going to go only with the first term alone. First term goes with like this: A minus K plus dagger is exactly AK minus. AK minus is this one. Similarly, A minus K minus will be AK plus dagger. So this term is replaced by this term, and this term is replaced by this term. I repeat, AK plus dagger. What is the value? A minus K minus. See here, A minus K minus. Simple logic. Similarly here too. Here A minus K plus dagger will give you A plus K with minus. See, A plus K with minus. So this will be replaced by this. This term is replaced by this term. So we have written the same term. So other things are not same thing. I have written this term here and this term here. That's all. See, AK plus I have written. This is replaced with AK plus dagger. See, AK plus dagger. This is replaced by AK minus. This is AK minus dagger is sir. See, AK minus dagger is sir, and AK minus. I have written this term here and this term here. That's all. And this term is replaced by this plus 1. We know already. So you have learnt in linear harmonic oscillator. Okay, AK plus dagger equals AK plus dagger, AK plus 1. So this is replaced by these two terms. Okay, so this is replaced by these two terms. You will have AK plus dagger, AK plus AK minus dagger, AK minus plus 1. This is replaced with number operator with a positive energy. This is replaced with number operator negative energy. So this is NK plus and this is NK minus. The total expression becomes H equals H bar omega NK plus NK minus plus 1. We know already that the quantized energy of the photon for the real scalar field is given by this expression. We know already. So this expression. And here, as I said, real scalar field means you have a photon that will create particle and antiparticle. The particle it itself will go with the antiparticle. Okay, here the same particle, the particle with antiparticle. Here it is not the same. The particle go with another antiparticle. Another antiparticle will go with some other particle. More than 2 systems. You just divide now. NK divide into that part. NK plus half, NK minus plus half. Plus half and plus half will give you 1. So that's why we can write this as NK plus NK minus plus 1. So this is for the positive field and this is for the negative field. Hence, for a positively and negatively charged particles, we can write the energy equation as exactly like this. So this is quantized energy of the photon. So this is your quantized energy of the photon. This is applicable for the boson. Spin equal to 0. So that's why we have chosen Klein-Gordon equation. Klein-Gordon equation applicable only for the for the particle where spin equal to 0 for the bosons. So this is the expression for the energy of a complex field. Similarly, we can derive for the momentum. Similarly, we can derive for the momentum and total charge for the scalar complex fields. So there are three expressions, and we have derived only for the energy of the complex field alone we have derived. So now AK plus stands for annihilation operator. We know already. AK plus dagger stands for the creation operator, and N plus is a number operator for the scalar particle energy h bar omega, momentum k, and electric energy for the positive charge for a positive field, and this is for the particle. Similarly, you just go for the antiparticle exactly like this. So this is for your annihilation operator for the negative one. So this is for your creation operator, and this is for your number operator, and for scalar particle energy h bar omega, the momentum k, and the electric charge minus E, and this is for the antiparticle. So one is for the positive charge, another one is for the negative charge. One is for the particle and another one is for the antiparticle. So the above operators have corresponding interpretation for particles of charge and momentum. We can identify the quanta with positive charges as the particles and those with negative charges as antiparticles. See, quanta of energy, sigma is here. Okay, sigma is here. So quanta of energy. When you are going with, for example, n equals 0, this is 0 point energy. N equals 1, 2, 3, it goes on. So these are all quanta of energy. So we can identify the quanta with the positive charges as the particles and those with the negative charges as antiparticles. The Hamiltonian, momentum, the total charge operators, they are all expressed in terms of number operators. So everything will go only with the number operators. See, here we have derived only for the energy. Similarly, you can derive for the momentum. Similarly, you can derive for the total charge. Everything will be in terms of number operators. Number operators means 0, 1, 2, 3. So they are all quantized energy, quantized momentum. Charge also is quantized operators. Hence, they are all diagonal elements. So we will have only diagonal elements. Only then we can get the real values. Okay? Any doubt? So we started with real scalar fields. All the expressions, whatever the real scalar fields, the same expressions we have obtained, we can take all those expressions for the complex fields too. And we started with the Klein-Gordon equation because this is applicable only for the spin zero particle for bosons. And we used field operators in terms of creation annihilation operators through Fourier transform. So we have the expressions already. And we used Klein-Gordon equation, we substituted for creation annihilation operators, and we have used commutation relations, and we have obtained the results for the quanta of energy of the photon. So real field stands for a photon creates particle and thereby antiparticles. Okay, single particle and antiparticle, the same thing, the same particle. Whereas if it is more than 2, then we will have to go for the complex scalar fields. Okay, so that is here. We will see in the next class. Okay, bye students.